Here's a short lesson on 11.7, areas of volumes in similar solids, and we'll do some sample problems at the end. What is a similar solid? Same thing as a similar figure, only in 3 dimensions. They have the same shape and all their corresponding dimensions are proportional. On the left is an example of a similar solid because they have the same scale factor. 3 times 2 is 6, 2 times 2 is 4, 3 times 2 is 6. On the right, we have an example of one that is not, or 2 figures that are not similar solids because they don't have the same scale factor. 2 over 3 is not equal to 3 over 6. Are these 2 cylinders similar? We take the ratio of their dimensions, 6 over 5 equals 12 over 10. They're both reduced to 6 over 5, so they're similar. What we're looking at in this lesson is the ratio of the volumes or the ratio of the surface areas of similar solids. Here we have 2 similar prisms. The scale factor is 2. 3 times 2 is 6. 1 times 2 is 2. 2 times 2 is 4. If we calculate their surface area, we get 22 to 88, or a 1 to 4 ratio. And if we calculate their volumes, we get 6 to 48, or a 1 to 8 ratio. Now, look at the difference, 1 to 2, 1 to 4, 1 to 8. If we take the ratio of the scale factor and square it, we get the ratio of the areas. If we take the ratio or the scale factor of the side lengths and cube it, we get the ratio of the volumes, which makes perfect sense. If we're just talking one dimension, 3 times 1, 2 is 6. If we're talking area, that's 2 dimensions. So we have that extra multiple of 2 times an extra multiple of 2, which is 2 squared, or we're taking that scale factor and multiplying it twice. And if we're doing volumes, we have that extra 2 times 2 times 2, or in other words, we take that scale factor and we multiply it by itself 3 times to get the new volume. So the area and volume of similar solids, if the scale factor of 2 similar solids is A to B, the ratio of their corresponding areas is A squared to B squared, and the ratio of their corresponding volumes is A cubed B cubed. Now, how do we use this? In this example here, we're given 2 prisms. We're given their volumes, 729 and 1331, and we need to come up with their scale factor. We know that the cube of the scale factor is the ratio of the volumes. We set our scale factor to our unknown, A over B. We cube it. We set it equal to the ratio of the volumes. In order to solve this, we take the cube root of both sides. The cube root of 729 is 9. The cube root of 1331 is 11. The scale factor is 9 over 11. In this example, we are given 2 lateral areas of paint cans, 1019 and 425. We're given the volume of the smaller can, 1157, and we're asked to find the volume of the larger can. How do we do that? We first have to find the scale factor. We know the scale factor is, or the ratio of the square of the scale factor is equal to the ratio of the surface area of the cans. We have the lateral surface area of 1019, and we have the lateral surface area of the smaller can, 425. The ratio of those surface areas is equal to the square of the scale factor. I set my scale factor as the unknown, that's what I'm looking for. The square of the scale factor is the ratio of the areas. I take the square root of both sides to find my scale factor. And I'm going to go ahead and leave my scale factor in this form to make sure it's exact. Now I use the formula that says the cube of the scale factor equals the ratio of the volumes. I know the volume of the smaller cylinder. I leave the volume of my larger cylinder as my variable. And now I simply solve. I multiply both sides by 1157. At this point, I can plug them in my calculator. I get the volume of the larger container at 4,295. Let's look at a couple examples. First of all, how to find scale factor. In number 11, I'm given the volumes of two similar cones. I am asked to find the scale factor. I know that the ratio of their volumes is equal to the cube of the scale factor. So I simply set up my equation, ratio of volumes equals cube of the scale factor, reduce my fraction, take the cube root of both sides, and I get 5/6, which is my scale factor. For number 14, I'm giving two surface areas. I know that the square of my scale factor is equal to the ratio of the surface areas. Ratio of surface areas, 20 pi over 125, is equal to the square of the scale factor. I reduce my fraction. I take the square root of both sides to get my scale factor of 2/5. Now let's look at a problem a little more complex. I am given two surface areas of similar figures. I'm given the volume of the larger figure. I need to find the volume of the smaller figure. First step, I have to find my scale factor. The ratio of my areas is the square of the scale factor. I reduce my fraction. I take the square root of both sides, so my scale factor is now square root of 124 over square root of 279. In order to have an exact answer, I'm going to leave my scale factor like that. And now I use the fact that the scale factor cubed is equal to the ratio of the volume. I know the larger volume is 810. I'm looking for the smaller volume. I set up my proportion. I multiply by 810 on both sides, and I found the volume of my smaller container. Number 18, I'm given two volumes in this case of similar solids, and I'm given the surface area of the smaller figure. I need to find the surface area of the larger figure. How do I do this? I first need to find my scale factor. I know the ratio of my volumes, 27 over 125, is the cube of the scale factors. I take the cube root of both sides. The cube root of 27 is 3. The cube root of 125 is 5. My scale factor is 3/5. I know that the scale factor squared, 3/5 squared, equals the ratio of my surface areas. I have the surface area of my smaller figure. I want to find the surface area of my larger figure. 9 over 25 equals 63 over x. My larger figure has a surface area of 175 inches cubed. Number 20, I have a volume of 2 and a volume of 250 yards cubed. These are similar solids. I have a surface area of the smaller figure is 13. I want to find the surface area of the larger figure. I first have to find my scale factor. The ratio of the volumes equals the cube of the scale factor. I take my ratio of volumes, I simplify that fraction, and I set that equal to the cube of my unknown scale factor. I take the cube root of both sides. My scale factor is 1/5. I know my scale factor squared is equal to the ratio of the surface areas. My smaller surface area is 13. I am looking for the larger surface area. I take 1 squared over 5 squared equals 13 over x. I solve for x, which is 13 times 25, or 325 yards. So those are about the extent of the problems that you'll need to do in the homework on Math Excel. Just remember again that the ratios of the surface area and the ratios of the volumes are related to the scale factor, and that the ratio of the corresponding areas is the scale factor squared, and the ratio of the corresponding volumes is the scale factor cubed.